All right. So we're gonna go ahead and do 3.1, guys. I'm gonna give you about 2.5 minutes on this slide to copy this down. So we're starting chapter 3. So chapter 3 is 3.1, simplifying algebraic expressions. So I'm in this lesson, we're going to be learning some definitions. You notice in the bottom in blue, we have 3 new definitions. And then we have a note. A note is pretty much just kind of an explanation of a small a component in this lecture. And then the green where it says recall. The recall means I'm asking you or bringing up information that was shared in the past, whether it be in this lecture or another math class. But since this is elementary algebra, this is pretty much one of the first classes everyone uh, tends to, the first class people take in college. All right, class. I'm gonna go ahead and read over this slide. And if anyone needs more time after I go over it, I will add a minute or two to the timer. All right, so recall, algebraic expressions is just a combination of numbers or variables and operating symbols. Operating symbols is just like addition, subtraction, division sign, or a multiplication symbol. Now take a look at this note where it says terms of an expression. Well, terms of an expression pretty much means what is a term, right? Well, a term of an expression, they're separated by a plus sign or a minus sign. Now take a look at the 3 definitions. The first definition is constant term. A constant term is just pretty much a number. That's pretty much what a constant term is. But you are going to be hearing the term constant term in this lecture and in other classes. So it's very important that you understand how to call what else does a mathematician use to call a number, which is just a constant. Then definition 2 is we have a variable term. A variable term just pretty much means, is there a variable in it? Like 3x, that's a variable term. 10x squared is a variable term. 7y to the cube power, that's also a variable term. Now the new numerical coefficient, guys, well, guess what? Some variable terms have numbers in front of it. Like for example, 7x, guys, that's a variable term, right? But the numerical coefficient, the coefficient of this term is 7. This is the numerical because it's the number factor of a variable term. Now remember, because the reason why it's a number factor is because factors are pretty much 2 things that multiply. That's what factor means. Things that multiply. Things that multiply. And remember in other lecture, what did I say when we have a number and letter next to each other? They're being what? They're being multiplied. All right, what questions do we have on any of these notes? Now, would any student like extra time writing down any of these definitions or slide?
I would.
Okay, would you like 1 minute or 2 minutes?
2.
All right. When you're the ones who needed more time, just let me know done. When you're done, if you finish before the timer. Because you know me, guys, I do not mind giving more time to write notes. But if I don't need to give all the time that was requested, like I can say shave off a few seconds to keep moving, I would love that. So just chat, but you can chat it to me or in the chat, just say, hey, done, sir, done, I'm good. Now, another tip for people writing notes who need time or you want to do this in your own pace, you can always rewatch the video after I share you out, email you guys the link, or you can just screenshot the slide before or after I'm done, or both, or take a picture with your phone, and then just copy it after class or whenever you have time. All right, Damien, that was my timer for 2 minutes. Are you good to go for me to move on?
I'm just screenshotting it right now. I'll get it later.
All right. Let's go ahead and move on to slide number 2, guys. So examples of terms. So go ahead and give you all 1 minute to write this down. Make sure you skip some lines, Damien, in your notebook so you know where to write what you need to finish. And then we have examples of terms, guys. So look at the first expression, x plus 3. While you guys are writing this down, how many terms do y'all think there are in x plus 3? Just say there's 1 term, 2 terms, 3 terms. You can unmute and let me know or type it in the chat. How many terms do you think x plus 3 is? Now, if no one says anything, I will call on random students, guys. So pick your poison. Want to be called on or want to just speak up? How many terms do y'all think x plus 3 is? All right, Adelaide said there's 2 terms. X plus 3, 2 terms. Does anyone agree or disagree with Adelaide about there being 2 terms? Nicholas agrees. All right, let's find out. 2 terms. Remember, every term is separated by a plus or minus. So that's 1 term. Plus is separating it, and 3. So you are correct. It is 2 terms. All right, let's look at the bottom one. 3y squared minus 6y plus 4. How many terms do y'all think there is in this expression, class? Do y'all see 1 term, 2 terms, 3 terms, 4 terms, 5 terms? Let's see what people are saying in the chat. So Nicholas is saying 6 and Noel is saying 3. Nick and Noel, or Timothy, do y'all want to share which ones do y'all think are the different terms? Can someone tell me a term so I can highlight it? What's one term from this bottom expression?
3y
3y
squared.
to the second power.
That is one term. That's correct. Can someone name me a different term?
6y
That's a different term. Can someone name me another term?
and 4.
Ah, so in total, we only have how many?
3.
There we go. Good. Any questions on how many terms, guys? It's very important that you guys know how to determine the difference, okay? Genevieve, your first answer was right with 3. What made you think was the fourth term, Genevieve? What was the one which part was confusing you that made you feel there was a fourth one?
No, you said what's the last one and I put 4.
Oh,
Yeah.
my bad. So you were right. Good job, Genevieve. Thank you for clarifying, man. Okay, cool. And then Nick, do you feel better now seeing 3 terms instead of 6, Nick?
Yeah, I understand where I went wrong.
Okay, good. All right, that's my biggest takeaway, guys, is are you able to understand more after the discussion? Okay, that's the key here. All right, there will be expressions where terms have like terms, and a like term is they have the same variable factors with different coefficients. Go ahead and give you a minute, 2 minutes to copy this down. If you look at the little chart below on like terms and unlike terms, I put that chart there so you could have examples of what are like terms and what aren't like terms. So whenever expressions have like terms, it's very important that we combine like terms. Does that phrase make sense? Remind you of anything? Combining like terms? Did anyone hear that in another math class when they were younger? And the phrase was combining like terms. Does anyone remember that phrase in another math class?
Yeah, I remember.
Good. We're gonna be touching base on that phrase today's lesson. So another way to think of combining like terms, it's like you bought a lot of fruit, or like your parents bought you a lot of fruit and you have to separate them. Well, we all know that we're gonna put the apples with the apples, oranges with the oranges, bananas with the bananas. It's the same thing in algebra. We're gonna combine the x's with the x's, y's with the y's, and so on and so on. Now, while you look at the like terms, guys, do y'all think that y and y squared are the same, are like terms, or do you think they're unlike terms? Y and y squared. Would you say they're like or unlike? So they both have a y, just one y has an exponent. So class, do y'all think, would y'all say the y and y squared are like or unlike terms? What do y'all think? I'm gonna read a definition. Go ahead.
They would be unlike, because in the like terms you have I know they're not the same ones, but if it was a y, there's one in like terms and unlike terms with the square.
Ah, so the square is what makes them unlike, correct, Adelaide?
Yes.
Okay, thank you, ma'am. Does everyone understand that they're unlike terms because one has a square exponent and the other one does not? Does everyone understand the difference? Because I would hate for you guys to have a problem on your test that says to simplify, and then there's one that says 6y plus 2y squared, and that you guys put a y squared. I would hate for you guys to do that, because is that correct? Can we combine 6y and 2y in this example here?
Another way you can see that it's like if they were twins, one of them fraternal twins, instead of being like identical, they're fraternal. So one of them has a different thing.
There you go. There you go. That's a great real life example to think about it like. Thank you for sharing, Adelaide. All right, so now before we begin some examples, we're gonna go make sure you write this property into your notebook, guys. It is the distributive property. Does anyone ever remember hearing the distributive property in another math class? So it's saying that if A, B, and C are numbers, then AC plus BC is A plus B parentheses with a C after it. Now, the C isn't always going to be after the parentheses, right? It's something's going to be like this as well. C parentheses A plus B. Just like this one here is not always going to be second. It's going to be also first as well. The C can be in this order. Because remember, the order of multiplication does not matter. Because we know 2 times 3 is the same thing as 3 times 2. So I'm gonna go ahead and give you about 2 minutes to write this slide down, class. Very important you write this property down. Remember, in mathematics, a lot of, and you know, in this class and other classes after mine, math courses, you will be given properties and formulas. And it's very important that you write them down and understand those formulas and properties, because you'll have to use them to justify some of the work you'll be doing in this class or in the class you're taking. All right, all right. So anyone need more time to write this property down, class? Does anyone need more time? Speak now, forever hold your truth. All right, thank you for the heads up. Let's move on. Here's example 1, guys. There's 3 different examples though. There's A, B, and C, all right? I'm gonna give you a minute to copy down the instructions and A, B, and C down. I'll give you a minute and 30 seconds. Now I'm gonna begin working it out, okay? Because the key to this example is when you see this expression, do y'all see like terms or do you not see like terms? Can we combine them? How do we combine them, etc.? You know? So, and I won't get started until you're done, till the timer goes off. Excuse me, excuse me, excuse me. All right, that was the timer, guys. I'm gonna go ahead and get started. So look at example A, 4x plus 6x. They're both x terms, so yeah, I would say they're pretty much like terms. So I'm gonna highlight them the same color. They're both yellow, so I could combine them. So I want you to think of x as apples. I have 4 apples and I'm adding 6 apples to my collection. So in total, I'm gonna have 10 apples. But remember, apples is just x. So the adding of this two is just 10x. And we're done. Now look at B. B is y minus 5y. Well, they're both y, so what is that? They're both like terms. But how do we combine that, right? So the first y is what number is invisible in front of the first y, class? Ah, good job, Jacob. There's an invisible 1, right? And if you have 1, but you spent 5, you're still gonna owe 4. Now let's take a look at C. Out of the there are 3 terms in C. Can someone tell me out of the 3, which ones can we combine?
3x squared and 5x squared.
And total gives us how many x squares?
4.
So remember, hey, gotta be careful with that. Because we're doing 3x squared plus 5x squared. So in total, 3 plus 5 is 8x squared. But notice how -2 is still there, and we can't combine -2 because it's not a like term. So we're just gonna bring that down and we're done. Does everyone understand how we went from 3x squared plus 5x squared minus 2 to 8x squared minus 2? Is everyone with me? Because now we have our first practice problem, class. Would y'all like 1 minute, 2 minute, or 3 minutes for these practice problems? There's 3. So 1 minute, 2 minute, or 3 minutes. All right, I'm gonna give you 3 minutes starting now. Good luck, class. Now remember, I encourage you guys to type in what you get for each one in the chat and see if you can match what other students get, guys. Say agree or disagree. Now make sure you put A, write the letter A and then the answer. And then B, answer. And then C, answer. And then you can say agree with A, agree with A, or agree with B, whatever, you know, and another way to learn to chat with each other, guys. Gabby, is something missing after the -6 for your A? Think about it. There you go. Good, good, good. And then your B, you put 7A question mark. You're not too sure? Or is that like you didn't mean to put the question mark? And that's fine, Gabby. You know, look at Jacob. Jacob got something what you got. So could be that you're both right. Could be you're both wrong, right? We don't know. We'll see what the class says before I interject. A great initiative so far. Come on, guys. Jacob and Gabby are still in the show. How's everyone else doing? Good. If you see how Nicholas put the 2y squared, that caret symbol, the rooftop is gonna be shift 6. That's the symbol, that's called a caret symbol. A caret symbol. Caret is always used to denote exponents. So 5 squared, that's how you write 5 squared. So Nicholas put 2y squared plus 7. All right. That was the 3-minute timer, guys. Is there any questions y'all want me to go over for each one? So for A, what did we get? For A, we got some people saying -6m. For B, we got 7a. And then for C, I've seen 2y squared plus 7. If you got -6m for A class, you are correct. If you got 7a for B, you are correct. If you got 2y squared plus 7 for C, you are correct. The reason why B is 7a, because there's a by itself, there's an invisible 1 in front of it. Remember that if there's no number in front of a letter, there is an invisible 1 class. All right, any questions so far on these practice problems? Because the expressions are going to get more difficult as we move forward. Any questions before we move on? All right, let's keep going. So now we have the properties of addition and multiplication. So we have the commutative property of addition and multiplication. Now, I'm gonna go ahead and give you about 4 minutes on this, guys, or and I'll probably give you like 4 minutes, yeah. And if I need more time, I'll add another minute or 2. Now, the reason why this property is put in this journal is because when I was younger or in college, a lot of my other professors kept asking the class, what's the commutative property? What's the associative property? And I had no response, guys. So apparently these properties that are in the yellow box right now, these were actually supposed to have been taught to us in high school. But I can tell you right now, in my high school career, I was never once told these properties. And I found out as a teacher that I didn't find out is because my teachers didn't think we would care to know it. And they took it upon themselves to not tell me about it. So when I went to college, it bit me in the ass. And now you guys are in college. Did any of you guys see these properties in high school? If you remember. Oh, nice. You had a good high school then, ma'am. Good. Very good. Now, pretty much, let me explain what these properties are. So a property, I know I keep saying it, right? Well, we're keeping a reminder is a property. A property is a mathematical truth. It's a mathematical fact. So let's look at the properties of addition and multiplication. It's saying that if A, B, and C are numbers, then we can say that A plus B is the same thing as B plus A. That is what this property is saying, that A plus B is the same thing as B plus A. That is the commutative of addition. So that's why when you see the numbers 1 plus 2, we can rewrite it as 2 plus 1, and it will stay the truth. Notice how it's only addition. Now let's look at the second one. A times B is the same thing as B times A, which is the same thing as commutative of multiplication. Now, before I move on to the second half class, do y'all think that subtraction is commutative? Do y'all think 3 minus 1 is the same thing as, hold on, let me rewrite that. Do y'all think 3 minus 1 is the same thing as 1 minus 3? Is subtraction commutative? Yes or no? What do you
No.
think? It's not, right? Because 3 minus 1 is 2, where 1 minus 3 is -2. So no, subtraction is not commutative. So that's pretty cool to understand that operations have their limits. So let's look at the second property, the associative property. So they say that the order of adding and multiplying two numbers can be changed without changing their sum of product. So the associative property is saying that we can group letters in different orders. So the same three numbers, A, B, and C, if we add A and B first and then C, it'll be the same thing as adding B and C first and then A. So we can group the different terms together, but we get the same thing. We don't change the sum or the product. Very beautiful stuff, class. Very beautiful. I did put this helpful hint so you can personally see examples with actual numbers and how they do make sense, and that they're not true for subtraction or division. All right, class, would anyone like additional time to copy the slide down? And if you need more time, would y'all like an extra 1 minute, 2 minutes, or 3 minutes? Okay. I'm gonna see if anyone else. Everyone is saying 1 minute. Okay. We're gonna add 1 minute just because the request has only been 1 minute. If anyone needed more than 1 minute, please feel free to just put it in the chat, class. All right, that was the extra minute. 1 second. All right, class, let's go ahead and move on. Hopefully that 1 minute was good. Was that 1 minute enough, Jacob and Adeline? Excellent. All right, let's move on. All right, example 2, class. I'm going to give you about 1 minute to copy this slide down. So you notice how the expression in example 2, it says simplify 2y minus 6 plus 4y plus 8. The way we simplify a class is by using the property or the process of CLT. Can anyone remind the class what CLT stands for? It's combining like terms, class. So this is an example, so I'll go ahead and work it out for you. So first, when you see an expression like this in this manner, you ask yourself, can I combine 2y with anything else in this expression? If you look closely, you see that 4y is another term, like term. Then I look at -6. Well, what can I combine -6 with? Well, I can combine -6. That's a constant term. That's just a number by itself. Do I see any other numbers by itself in this expression? I do. I see the 8. It's a positive 8. So I'm going to go ahead and combine the two yellows, 2y plus 4y. That's going to go ahead and give me 6y. And then that's going to be right here, 2y and 6y. Well, the -6 plus the 8, you owe the bank 6, but I put $8 in there. So I'm going to get $2 to spend. And that's that. We are done. Can anyone tell me why I cannot do this? Can anyone unmute themselves and share with the class why we cannot do 6y plus 2?
Because the 6 and the 8 don't have a variable with them.
That is correct. So it's very important that you understand that they do not have the variable, so we cannot keep combining. All right, take a look at your practice problem, class. I'm gonna give you 2 minutes for the practice problem. Good luck. So Jacob put 7z plus 1. Does anyone agree or disagree with Jacob's solution? Good. If you said agree, you are correct. Are there any questions on this example problem before we move on this practice problem? Any questions whatsoever? Okay, let's move on. So example 3, there's 3 different examples. So there's example 3, 4, and 5. I'm gonna go ahead and give you guys 2 minutes to copy the instructions, and then 3 down, skip a couple lines, 4, or you can do it in the columns like this. Do 3 and 4 right here, and then I'll do 5 right here. Yeah, this is example 3, example 4, example 5. Example 3 says 6y plus 12y minus 6. Example 4 says 4x plus 2 minus 5x plus 3. And then 5 is 2x minus 5 plus 3y plus 4x minus 10y plus 11. All right, this is going to be some juicy examples, class. Let's see how they go. Because what we're going to be doing in this example, you'll be doing a little bit more complicated. We're going to use the same process that you're learning now. You'll be seeing them in different equations to solve. So the equations we'll get later on this semester is they're going to have you do algebra steps of combining like terms and distributing, and then solving for x, moving things around. All right, let's look at example 3. 6y plus 12y plus 6. Well, from looking at this, I can tell that 6y and 12y are like terms. When I combine those two, I am going to get 18y. And then minus 6 cannot be combined, so we are done. Let's look at example 4. We have 4x, which can be combined with negative 5x. And then I have plus 2 that can be combined with 3. What was I gonna say? So 4x minus 5x. If we have 4, but we get rid of 5, you're still gonna owe 1, which is negative x or negative 1x. You don't have to write the 1 if you don't want to. Plus 2 plus 3 is just plus 5. And we're done here. And in example 5, we can combine the 2x with the 4x. We can combine the negative 5 with the 11. And then we can combine the 3y with the negative 10y. Well, I'm going to do the x's first because we want to go in alphabetical order. So 2x plus 4x is just 6x. Sorry about that. And then 3y minus 10y is negative 7y. Minus 5 plus 11 is plus 6. And we're done. What questions do we have on the steps that I took? Does everyone understand why I highlighted the colors that I did, class? Does everyone understand how I use the colors to do that? Now, if you don't have different colored highlighters at home and you want to separate your terms to use this as the technique, you can underline. You can underline all the x's 1 line, all the regular numbers, constants 2 lines, and all the y's 3 lines. And then you can just see which lines are which. That is another technique if you do not want to use highlighters. All right, ready? Let's move on. Here is the next set of practice problems, class. I'm gonna go ahead and give you guys 4 minutes to do these practice problems. Good luck. All right, Jacob is stating 18y minus 6 for the first one. For 3, 18y minus 6. Let's see if other people agree or disagree. Alright, so for 4, we have. I see two different answers. I see 8y plus 3. So for 4, we have. Sorry, my tablet stopped working. 1 second. So then we get for 4, I see 8y minus 3 and I see 8y plus 3. Let's see what people see the difference for 4, what people are saying. And then for 5, I get negative 9y. I see negative 8x. And I see plus 14. For 5. All right. That was the timer class. So, all right, let's look at number 3. 6y plus 12y minus 6. When you add the 6 and 12, it is 18y, and then the minus 6 is still there. So number 3 is right. Now for number 4, we have 7y minus 5 plus y plus 8. So those two y's, I'm gonna underline them. 7y plus y. We got 8y. Which is what? 8y, right? So the 8y is legit. Now the question is it plus 3 or minus 3, right? We have minus 5, right? I'm gonna do 200 lines for the minus 5 and 200 lines for 8. So minus 5 means we owe the bank $5. Plus 8 is we're adding 8 into our account. If we owe 5 and we put 8, do we have 3 or do we still owe 3, class? What's your final answer? I know the answer. This is just a practice for y'all to understand this. So is it plus 3 or minus 3?
Plus 3.
Plus 3. Now 5. We have negative 9y minus 8x plus 14. Well, let's combine the y's, right? So 1y, the y's would be 1 underline. The numbers will be 2. And then the x's will be 3. So the y's, negative 7y minus 2y. That, yeah, the negative 9y seems good. The 2 lines is the plus 2 plus 12. That is 14. Now let's look at negative 9x minus x. Well, negative 9x, we owe 9 to the bank. That minus x, are we spending 1 more or are we adding $1 to our account?
Spending.
We're spending. So instead of owing 9 now, we're gonna owe how much, class? What was that? You cut off?
10.
10. That'll be negative 10x. That's the correct one for number 5. Any questions on how we got number 5, guys? Any questions? Now, another way to have written number 5 is you could have put negative 10x minus 9y plus 14. And they mean the same thing. All right, let's move on. All right, next slide. Now here's examples 6 and 7. This is other examples, guys. I'm gonna give you 1 minute to copy them down. So we're doing 5 times 3y and -2 times 4x. Whenever you're multiplying a constant with the variable terms, all you have to do is multiply the numbers, class. Only multiply the numbers. So it'll be 15y, correct, Jacob? Good mindset, sir. So 5 times 3y, you multiply the 2. 5 times 3 is 15, and don't forget the y. And then number 7, -2 times 4. Remember, a negative times a positive is negative. 2 times 4 is 8y. And we're done with the example 6 and 7. What questions do we have on multiplying? Any questions so far? All right, let's move on. We have example 8, 9, and 10. Now this has to do with the distributive property, guys. I'm going to give you 1 minute to copy example 8. Now be very careful because this is I am surprised of how much complication distributive property gave to students last semester. I want to make sure to avoid that confusion this semester, okay? So follow along with me as you write and as I work them out, okay? And ask any questions on any steps I took that confused you. Por favor. Five seconds before I get started. So if you look at example 8 class, at example 8, we have a 5 parentheses x plus 4. So what's happening here is we're going to multiply the 5 to the x, and then we're going to multiply the 5 to the 4. So what's happening here is we're going to do equals 5 times the x, and then it's a plus, right? Plus 5 times 4. We're multiplying the 5 with both the items or terms inside the parentheses. Well, 5 times x, we know is just 5x. We know 5 times 4 is a positive 20. We cannot combine any further, so we are done. Any questions on the arrows and the steps we took? After a while, we will, in the beginning, I want us to write this step down, but once you know what's happening, we can skip this step once we know, okay? Let's look at example 9 class, example 9. Would anyone like a minute to write this down, or can I get started? Would anyone like a minute to get this example written down? If not, I'm gonna go ahead and just start working it out. I don't mind if you need a minute to copy it. Okay, I'm gonna go ahead and jump on it. So we're multiplying -3 parentheses 5a plus 2. This is still distributive property, even though the instructions do not say that to distribute. We have to know when we have a number next to parentheses, we have to distribute. So we're gonna do -3 times 5a plus parentheses -3 times 2. So let's multiply. -3 times 5a is negative 15a. Negative 3 times 2 is a negative 6. Class, what happens when we have a plus a negative? What operation does this condense to? Who remembers? Well, everyone should remember that plus and negative is the same thing as minus 6. Bring down the 15a and we're done. Now, if you knew negative 3 times 2 was going to give us a negative 6, you could have just skipped this step if you wanted to. I want you to know that that is okay to separate them. All right. Any questions so far? Now, look at example 10. Distribute multiply 8 times x minus 4. So I'm going to draw my arrows. You notice how I draw my arrows to every term. We're going to do 8 times x minus 8 times 4. Well, 8 times x is 8x. Minus 4 times 8 is negative 32. And we're done. Any questions, guys, on these examples so far? Any steps that we took? Because you are going to be trying this out in your own on the next slide for practice problems. All right, well, here you go. Good luck. I'm going to give you guys about 4 minutes. All right, class, let's look at any of these practice problems, guys. So thank you, Jacob and Yesenia, for sharing what you've got. Uh, Jacob for putting all three, Yesenia for confirming for three or asking for three. Any questions on practice number 8, the first one? Thank you, Kaya. We have 8Y. Okay. You have the same thing as Jacob. Excellent, man. Thank you, thank you. Now, any questions on any of the work? So let me go ahead and tell you if you're right or wrong, guys. If you got 8Y plus 16 for 8, you're correct. If you got 21A minus 15, you are correct. And last but not least, 30 minus 6Y is correct. So we got these three, good job. Now, if you didn't get these three, are there any problems you guys would like me to work out or explain before I move on?
I wasn't, the internet was like on my part, it was not good. So we're just distributing the number outside the parentheses with the ones inside. Or
That
like
is
the
correct.
variables.
Yep, just like, were you here for examples 8, 9, and 10, Adeline?
Mande?
Were you able to see these examples on the board, 8, 9, and 10? Were you,
Yeah,
okay,
I
perfect.
had an idea of what to do. I just wasn't sure if it was right.
No, for sure. I just wanted to put it on to see if you needed to take a picture of this slide or not. So you already wrote these down, you're good for these examples? You don't need to write?
Yeah,
them? Okay.
I'm good.
And
Thank
then
you.
No, you're good. All right, cool. Thank you for asking. All right, let's move on, guys. Now we have the same property we're putting, but now we have an extra step. Now we have to combine and simplify. So example 11, guys, I'm gonna give you guys about a minute to start setting it up, excuse me, and I'll begin working it out. All right, look at example 11, the first one. We have 2 plus the parentheses, right? So I'm gonna go ahead and get my arrow. Let me go to my pin. So I'm gonna put an arrow with the 2 and the 3, 2 with the 7x. 2 times 3 is 6. 2 times 7x is 14x. And then I'm gonna bring down the minus 15. Because why am I not multiplying the 2 to the 15, class? Can someone clarify why they think I'm not putting an arrow with the 15 to share with the class? And if you don't know, you can type in I don't know and I'll tell you why.
Is it because it's not inside the parentheses?
It's not inside the parentheses. That's correct. Thank you, ma'am. All right, so now we have to combine the like terms. 6 is a constant and so is negative 15 and 14x is the x term. So I'm gonna put 14x first. You always want to put the letters first. And then 6 minus 15 is negative 9. And we're done. Now look at the next example here. Simplify with the 2 parentheses, guys. Can someone tell me how many times we're gonna be distributing?
2.
Why? Yeah, 2 times. It'll be the negative 2 to these 2 terms. Then it'll be the 4 with these 2 terms. And we know that distribution is multiplication. So let's go ahead and do it. Negative 2 times x is negative 2x. Then it's gonna be negative 2 times negative 5. We know a negative times a negative is positive, and 2 times 5 is 10. And then it'll be 4 times 2x is positive 8x. And it'll be 4 times positive 2, which is just a positive 8. Well, I know that I can combine the x with the x and then the number with the number. Now, negative 2x plus 8, I owe 2, but deposit 8. So then I will have 6x left over. 10 plus 8 is just 18. And we're done. All right, now we're on the last one. We have a negative parentheses x plus 4 plus 5x plus 16. This negative, guys, is an invisible negative 1. We're going to distribute a negative 1. Now, the beautiful thing about distributing a negative 1 is the signs flip. Positive numbers become negative and negative numbers become positive. But if you look inside the parentheses, the x and the 4 are positive. So just the x becomes negative and then the 4 becomes negative. Then I bring everything else down. And then I look, I can combine x with x, constant with constant. Negative x plus 5x is 4x. Negative 4 plus 16 is positive 12. And we are done. Any questions on what we did on this example class? Any questions at all before we do the last practice problems? Would anyone need an extra minute to copy this slide before I move on, guys? Does anyone need more time? All right, there's no needed for more time. So here is the last practice problems of today. For not today, but for this lesson. So we have A, B, and C. I'm gonna go ahead and give you guys 4 minutes to work on these. All right, that was a timer. All right, so for practice 11, guys, we have 10y minus 23. If you got that, that is correct. For the second one, if you got 3x plus 22, that is also correct. And the last one, 2y minus 13, that is also correct, class. So are there any of questions about any of these practice problems, guys? Any questions on what we do, or anyone want me to work them out? Any questions whatsoever? All right, I'm gonna go ahead and stop. So now let's take a look at practice 1 class. I'm gonna go ahead and give you guys a minute and a half. I'll give you 2 minutes to do practice 1. But any questions on example 1 and the steps that I took? Any questions at all? Okay, if there's no questions, good luck on practice 1. Remember, when you write the answer, make sure you write the variable 2. Nice, Jacob. X equals -8. Good job, sir. So Jacob did get a solution for us. Let's see if anyone can work it out themselves and see if they get the same thing as Jacob or something different. If you got the same thing, you write agree with Jacob. If you got something different, put disagree and put what you got. Good, good, good. Ten seconds left, guys. Does anyone need me to work out or explain practice 1 problem for today for 3.2? All right, you got x equals -8, like Jacob, for practice 1, you are correct. What questions do we have before I move on? Okay. Here is example 2. Notice how the plot thickens. We have 3 examples here. I'm gonna go ahead and give you 1 minute. Excellent, Jacob. I'm loving how you're working through the examples yourself, guys. That's one of the ways to stay on top of it. Now, examples, remember, I'm gonna start working these out. Let's go ahead and get into it. So 3y minus 7y equals 12. I'm gonna go ahead and draw a line down the equal sign, and I will remind myself that I can combine 3y with negative 7y because they're like terms, which gives me negative 4y. Bring down the 12. Now, when we have a number and letter next, remind myself that they're being multiplied. I'm gonna go ahead and divide both sides by negative 4. And that cancels out, and I get y equals negative 3. And I'm done. Now, I'm not too tired because I want to always kind of check my work. So I'm gonna plug that into these y's here. So it'll be 3 times negative 3 minus 7 times negative 3 equals 12 question mark. I'm gonna check my workout for this. So then 3 times negative 3 is negative 9. Negative 7 times negative 3 is positive 21 equals 12. Negative 9 plus 21 is 12 equals 12 is true. So this is the correct solution. Let's take a look at example, the second one right here in the bottom. Z over negative 4 or Z divided by negative 4 equals 11 minus 5. Now, before I multiply the negative 4 to get Z by itself, I can simplify the right side by subtracting 11 minus 5. 11 minus 5 is 6. Bring down the Z divided by negative 4. Now, the opposite of dividing negative 4 is, the opposite of dividing is multiplication, right? Now, when I multiply the right side, I'm gonna put a parentheses, because if I didn't write a parentheses and I just wrote this instead, I put times negative 4, I did the dot, I did dot negative 4. We can confuse this as subtracting, right? And put 6 minus 4, right? But that's not the case. We're multiplying these two together. So make sure that you guys don't get confused by that. So I know it's gonna be these two cancel out, so Z is there. 6 times negative 4 is negative 24. So we want to make sure we're right? Like, let's say you can ask me, Pacheco, is this good? And you have yourself, right? And guys, don't be using apps like Mathware, not like, because what if you, because I've had students use apps in this class and in my other classes at other schools, and they wouldn't do the correct process and they would overdo it and give me a different answer than it was just listening to the example in the notes. Like in the notes, I'm showing you how to do these things so you can learn how to do these things. So then we're gonna check out negative 24, right? So it'll be negative 24 divided by negative 4 equals 11 minus 5 question mark. Well, we know 11 minus 5 is 6, right? And negative 24 and negative 4 is positive 6. That's true. So this is the correct solution. Now, let's look at the last example, class. So I'm going to go ahead and put the line on the equal sign. Now, you got to ask yourselves, is there anything I can combine and simplify in the left side? And anything I can do on the right side? So then we combine the left side. 5x minus 4x is just x. Bring down the plus 2, right? Because they're not like terms. 7 minus 19 is negative 12. To get x by itself, I gotta do the opposite of plus 2, which is minus 2. What we do to one side, do to the other. So then I get x equals negative 14. And now I gotta check it out, right? I gotta test it. So check. So then I get 5 times negative 14 plus 2 minus 4 times negative 14 equals 7 minus 19 question mark. You're gonna have to use your calculator if you have to sometimes. So 5 times negative 14 is negative 70 plus 2. Then we have negative 4 times negative 14, which is plus 56 equals negative 12 over here on the right side, right? Then I do negative 70 plus 2 plus 56. And I get -12 equals -12, which is true. Which is, this is a correct solution. And we're done. Any questions on the process I use to simplify these equations? Remember I mentioned the other week that the equation process was gonna get a little more challenging, a little more difficult. Do you guys see what I mean? There's now gonna be more steps for us to unwrap to get the solution that we need. Is it impossible though? No, it is not. We just have to understand basic algebraic properties and steps. What questions do we have from this slide? Does anyone need an extra minute or two to copy these things down? All right. Let's see how you guys do on your own. Oh, yes, of course, Gabby, my bad. Let me go back and let me go down more. Is that good, Gabby? Or is that too much? Let me know when you're good to go, Gabby, when you're done. Okay, you got it? Okay, cool. All right. Now here's his practice problem, guys. I'm gonna go ahead and give you guys I'll give you 5 minutes. And if we need more than 5 minutes, I'll add more. Good luck. And if you guys get stuck on any of these and you want to ask for help, you can just ask me a question during this session, this part. Like if we're in the classroom, you guys would still be doing this and you would just raise your hand if you get stuck, you know? So you can still ask me for help, guys. You're just doing these things at home. All right, guys, that was the timer. So we have y equals 20 for 3. Jacob, were you able to get 2 yet, Jacob? Or anyone? All right, yeah, a equals -6. Anyone wanna share what else they got, guys? Anyone wanna say they got the same thing for the first one, -5? So if you got -5 for M for the first practice problem, you're correct. We got -6 for the second one, you are correct. And if you got 20 for the third one, you're correct. Any questions, guys, on any of the steps or problems that we did in this practice set? Any questions at all? Okay. I'm gonna go ahead and stop here, guys. I feel like this is a good breaking point.